Hi there. So in this practical, we're going to look at how capacitors charge and discharge. So what I've got here is something called a breadboard. Now basically this is an electronics kit, and what we've got, they come up in various sizes. The one that we're using has a variety of different things inside. We've got variable resistors, we've got some capacitors, and we've got some LEDs. These are then linked with a 9-volt battery, as you can see here. So what happens is we put our 9-volt battery on this side here, so this is coming through, and basically we've got our positive and negative terminals, which basically link to each of these terminals on the top and bottom of the breadboard. What this allows us to do is basically insert various components to make up an electrical circuit. So what we're going to do now is we're going to set up a circuit which is going to look at how the capacitor charges, and then likewise it's going to look at how the capacitor discharges. So what I've got here is I've got a this is a 390 ohm resistor. I think you might be able to just see it here. So the resistor here works with the green LED, which we're going to be working on. The LED, this will control the amount of current which is flowing through the LED that we've got. So what we do is we set up, we place one end of our resistor in line, as you can see here, with the positive terminal. We then plug this into just one of the sockets that we've got here. And then what we're then going to do is then take our LED and stick it in so it's in line with the resistor. Next thing we're going to do is take our capacitor. Now our capacitor, as we've got here, I'm not sure if you can see it under the camera. As we focus, maybe not. Basically, what we've got here, it says 220 microfarads. That's 220 times 10 to the negative 6 farads. Now, it's basically got a negative terminal here, and I'm going to place my negative terminal so it links with the negative terminal at this point here. So we plug it in, and then what we need is a feeder wire. Now the feeder wire I'm going to place right next to the capacitor. So we've got our resistor going straight into our LED, and we've got our capacitor and our wire. So what we should be able to do is to take our fly lead and basically plug it in next to the LED. Now, what I'm actually going to do is just make sure my capacitor's discharged. Now, it's a very small capacitor, so there's no chance of an electric shock there. But basically what I did there was just put the two terminals of the capacitor together. By putting the two terminals together of the capacitor, what I'm allowing to happen is all the electrons on one side to move to the plate on the second side, and they equal out, so there's no net increase in electrons on either side. So I'm going to plug that back into my breadboard. We're all set up, so we will flow. When I flick the switch on, this resistor will allow current to flow into the LED, which flows through the wire, then flows onto the capacitor. Now the key thing is to watch what happens to the LED here. So we'll switch it on, and you'll notice that we got a flash. Now it then stopped. Now what that means is all the electrons are flowing through here, and they're rapidly moving through the capacitor, through the LED, and building up on the capacitor plate. But they move through so quickly, the result is the capacitor fills up so that the forces, the repulsive forces of the electrons in the capacitor match that of the battery. As a result, there's no net flow, and so the LED goes out. Now, at this point, this capacitor now is fully charged. So what I can now do is I can take another resistor. So I'm going to put another resistor over here. Now I'm just going to link that into my breadboard here. Okay, so I take my resistor. I then take my LED, and then I'm going to link my LED to, so it goes through the resistor, through the LED, and then into the connection here. So if I take this wire out, what I can now do, there's no source, so the result will be that I can add my wire in line with the resistor. It flows through the resistor and then through the LED, and we should see this light up. Remember, the switch is now off, so there's no electricity flowing through. Everything's coming from the capacitor. So this is the discharge. So what happens is it's going to flow through here, and you will notice the LED going on and then going out. So the electrons are moving through here, go through the LED, through the wire, and then back onto the opposite plate until they're equal. So basically, let's recap. So if I switch on, I can charge up my capacitor, and you'll notice this goes on. I switch it off, so I've got my fully charged capacitor. I move this fly lead so it connects with this circuit here, and we will notice that the LED lights up for a period of time, and that's as the electrons are moving through and back onto the opposite plate. As a result, the capacitor is now acting as a timing circuit. Now we can look at this in a variety of different ways. So what I'm going to do here is I'm going to change my resistor. Now the timing circuit will look at how quickly the electrons flow. Now if I slow down the electrons, it will take longer for the capacitor to charge. So this was let me just double check, it was a 390 ohm resistor which I've got here. Now what I'm going to do is I'm going to change that for a 1200 ohm resistor. So this resistor is a lot bigger. It's going to put up more resistance, which means it's going to slow the amount of current which will flow onto the capacitor. The result is I should see this light up for longer. So let's insert them all, and we notice that goes for longer. Now if I take that out, okay, and I swap this resistor, which is about 600, for this resistor, which is that 1200, make sure that they all link in together. Now remember, my capacitor is now fully charged. Again, I should see my light up for a lot longer, because this is going to slow down the flow of charge through that LED. Here we go. And you'll notice that it took a lot longer for that LED to go out. So what we're showing is that by changing the resistor, we can change the flow of current. We're also showing that when we switch on at the mains, we can get current flowing through a resistor, going through the LED, and the result is it takes time for that charge to build up on the capacitor. Remove the fly lead and go from the capacitor through a circuit, and we can then get another LED to light up, and we should show the discharge of the electrons from one plate to the other. So we go charging, builds up on this side, discharging, comes back onto the other plate. Okay, well I hope you found that useful. I hope it gives you an opportunity to see how capacitors work. Obviously in an electrical device we might be able to flip between the two, and we can switch. We always get continual switching between this, which allows us to continually deliver constant current to a circuit. Well, thanks for watching, and join me again.